Our paper subject is Designing Facades Based on Daylight Parameter, a proposal for the production of complex surface panelization. In our research, if we look at the literature background, we searched a lot of articles which are mainly in the circle of the energy performance-based and the interactive architecture. First, in the left side, we can see the cross-section between performance-based architecture and the interactive architecture in earliest researches. According to Kalay, performance evaluation is intended to form, function, and the context. By addressing environmental factors, designers could have encouraged to produce location-based solutions. Gagne also stated that there have been many different digital tools are developed for daylighting. Grobman was stating the importance of the computational design tools made possible alteration of complex forms. Evans focused on the designing facade of building forms in order to get higher performance. Adriances and Yao focused on mainly movable and adaptable shading systems. According to Fox, interactive architecture requires not just pragmatic and performance-based understandings, but also related with global environment. Connie searched about earlier design process based on the environmental data in order to get feedback. When we look at the related works, we can see the environmental conditions and the location-based parameters affects the building's forms or the facades of or the forms of facades in order to get sustainable buildings. The researchers also stated hierarchical changes of facades based on sun position. Some of them use it for shaping building forms, and some of them use this position for adaptable facades. When we came to our research methodology, actually we aimed to design a complex surface panelization system which could change according to the sun position. The steps of design framework are creating the analysis with Ladybug plugin, which gave realistic values of changes. Then we merged these output data with complex forms and analysis which are obtained as temperature data and the wind direction data could help and could provide us to create a color diagram and sunpath diagrams. Secondly, we could get these sunpath diagrams thanks to Ladybug plugin. Then we use those analyses in order to merge with the complex surfaces. By defining sunpath as attractive points in order to change the direction of the angles of hexagonal panelization. These color ranges and the diagrams are provided to form changes of facade panelization. Here you can see the definition part, which had realistic values of the analysis daylight and wind direction. When we look at those definitions, we could see the sun positions could defined as an attractive point in order to interact with panelization. We defined two prototypes in order to show, maximize, and minimize sunlight. The openings of facades panelizations changes according to the measure of the sun position. That is why panel systems could have hierarchical openings. For the conclusion part, the real-time daylight position was determined according to the data in daylight analysis of the facade panelization. And this direction, panel systems were created with more closed angles on the points receiving much sunlight and similarly Panel systems were created with wide angles on the points receiving less sunlight. A second design model was generated which is created with curvilinear but able to respond more clearly to daylight panelization. As the conclusion, it was observed that owing to these optimized prototypes, a model proposal could be developed that could change simultaneously. In addition, each panel system creates systems that can change and transform according to the different angles. For this reason, concerning the panelization method can be used in the future projects. It was determined that the fabrication process needs certain methods, such as one-to-one manufacturing and location-based production.